Welcome back to another video, everybody, in this computer organization course, and welcome back to my channel. So today we are moving away from the negative side, from sine magnitude, 1's complement and 2's complement, and we are now doing bit addition. In the next video we will be doing bit subtraction. So let's just get started right into the material. So single bit binary addition. So let's say we have two numbers, x plus y, and this would be C and S. C is carry and S equals sum. So what is an example of carry and sum? Say we're doing 5 plus 6, right? It's going to be 11, easy, right? But the way that we do it when we do this form is that we have 1 and we bring over the 10, which is 1. We bring over the 1 and it's 11, right? So this is the carry since we're bringing that 1 over, that 10 over, and this is the sum. So this is a form in which we know that we can do, right? But in binary form, it's different. The reason that it's different is that we only have two numbers. We have 0 and 1. So if we have two ones, right? If we have two ones, this is going to be 0 and it's going to carry of 1. The only reason why is because we cannot have more than 0 or 1. So let's just start from the beginning. So we have, let's add a single bit. 0 plus 0, right, is 0, which is the sum, and 0, which is the carry. We're not carrying anything over, and our sum of 0 and 0 is 0, right? Let's do another one. We have 0 plus 1, and the sum of this is 1, and we are not carrying anything over, so it's 0. So our carry and sum, so this addition right here is 0 and 1. Same thing for this, we're just flip-flopping it. 1 plus 0, the sum of this is 1. We are not carrying anything over. How about 1 plus 1? Right? It's just like saying 5 plus 5, right? It's going to be 0 here, and we're moving 1 over. So it's pretty much the exact same concept. So it's 1 plus 1. So we have a 0 here because it can only take the value of 1 or 0. It cannot be 2. This value cannot be 2. So we carry 1 over and be 1, 0. So our carry here is 1 and our sum is 1. But let's say we have a carry of 1, right? Let's say we carry 1 over, right? Let's say we carry 1 over. What if there's more numbers here, right? So this is the basic concept. So we have 1 plus some number x plus some number y, and we have a carry and the sum. So let's say we have 1, 0, and 0. Obviously, same thing like last time, it's only 1, and there's no carry. What about this one right here? 1, 0, and 1. You can think about it like this one right here. So you're adding these two ones. Obviously, it's going to be a 0, and you're carrying 1 over. And just think about it. It's like 5 plus 5. They're the same number, but it equals 0, and you're carrying 1 over. So that's the best way to look at it. And what about 1, 1, and 1? Think about it as 5 plus 5 plus 5. We have 5 left over, and we're bringing 1 over. So it's the same thing here. It's the same concept. These cancel each other out, and they bring the carry. And we're left with this one in this place. and we have that carry come over. Okay, so I'll give you an example. So what you want to do is you want to start off with the least significant bit. And this is exactly what we did before, but this is multiple bits. So we're going to move from the right to the left. Okay, so 0 plus 1. What is that value? It's 1, 0. You don't really have to think about this right here, but it will be 1. Oh, let me have a better color with that. It will be 1. Now we go to this side. This is the exact same thing. It's 1 plus 0. We have no carry over. What about 1 plus 1? 1 plus 1. Remember, it's like 5 plus 5. So it's 0 and you carry 1 over. So, same exact thing. 0 and you carry 1 over. 1. So what you're going to put in that place is this 0. And you're going to carry over the 1 into this place now. So now what we have here is 1, 0, and 1. And what did we have for that one? 1 plus 0 plus 1 is 0, 1. Think about it. It's like 5 plus 0 plus 5. 10. So we're going to have this 0 right here, and we're going to carry over another 1. So here we have 3 ones. What is 1 plus 1 plus 1? So these pretty much cancel it out. They go over, and we're still left with this 1 right here. So we are left with 1, 1. So we leave this 1 in its place and carry that 1 over. And we are left with 1. And 1 plus 1 plus 0. Think about it, it's like 5 plus 5. So it's going to be 0. And 1 is carried over. So 0. 1 is carried over. 1 plus 0 plus 0. We are just left with 1. And we have no carry over. And then 0 plus 0. So this is the addition. Let's just calculate these numbers, right? So 2 to the 1, 2 to the 2, 2 to the 4, and 2 to the 5. 2 to the 5 plus 2 to the 4 plus 2 to the 2 plus 2 to the 1 equals 32 plus 16 plus 4 plus 2. So what are we looking at? This is 48 and 54. Right here we are looking at 54. And this right here is 2 to the 0, 2 to the 2, 2 to the 3, and 2 to the 4. So there we are looking at 16 plus 8 plus 4 plus 1. We are looking at 29. So we're doing 54 plus 29. And now how about for this one, bottom right here? So what is the value of 54 plus 29? That is 83. So this value right here should be 83. Let's calculate it. 2 to the 0 plus 2 to the 1 plus 2 to the 4 plus 2 to the 6. What we're looking at is 1 plus 1 plus 2 plus 16 plus 64, 80, 83. So this value is 83. There you are. And these values match up perfectly. So let's do some more so we can get used to this. So let's figure out what the binary forms are first. Let's use a 6-bit register for this. This is fine, 6-bit. Alright, let's figure out what 7 is in a 6-bit register. It's 4 plus 2 plus 1, which is 2 to the 2, plus 2 to the 1, plus 2 to the 0. 1, 2, 3, 4, 5, and 6. 1, 1, and 1. Rest are zeros. Let's figure out what 12 is. 8 plus 4, which is 2 to the 3 plus 2 to the 2. 1, 2, 3, 4, 5, and 6. So 2 to the 2 and 2 to the 3. Rest are zeros. Alright, so let's add these. 7 plus 12 should be 19. So what is 19 in its binary form? This is just for us. This is just for us. We need to do the form here, but we'll put this on the side. 2, 3, 4, 5, and 6. So 19 is 16 plus 2 plus 1. So 2 to the 0, 2 to the 1, and 2 to the 4. 1, 2, 3, and 4. So this is what the answer should be. So let's do the work. 1 plus 0 is 1. No carry over. No carry over. 1 plus 0 is 1. No carry over. 1 plus 1. Remember, it's like 5 plus 5. We are left with 0, and we carry 1 over. So here in this place, we are left with 0, and we carry 1 over. 1 plus 0 plus 1 is pretty much like 1 plus 1. Same thing, 0, but we carry 1 over. And 1 plus zeros is just 1, and zeros plus zeros is zeros. Remember, there's no carryover here. So this is our answer. Does it match up to what we have? 0, 1, 0, 0, 1, and 1. Let's do it again. 17 in the form is 16 plus 1. Let's do 6-bit. Is 2 to the 4 plus 2 to the 0. 1, 2, 3, 4, 5, and 6. 2 to the 0. 1, 2, 3, and 4. Rest are zeros. Let's do 19, which is 16 plus 1 plus 2. It's 2 to the 4 plus 2 to the 1 plus 2 to the 0. 1, 2, 3, 4, 5, and 6. 1, 1, and 1. So what should that answer be before we even start? So it's 19 plus 17 equals 36. Equals 36 equals 32 plus 4, which is 2 to the 5, and plus 2 to the 2. 1, 2, 3, 4, 5, 6. 1 and 1. So this looks like it should be our answer, but let's go through it anyways. Let's go through the motions. 1 plus 1 is like 5 plus 5, so it's a 0, and you carry 1 over. So 1, 0, 1, it's like 1 plus 1, 0, you carry 1 over. 1 plus 0, 0 is just 1. 0, 0 is 0. 1 plus 1, it's like 5 plus 5. So 0, and you carry 1 over. And 1 plus 0, 0 is 1. So does this match up our answer? 1, 0, 0, 1, 0, 0. Alright, let's do a little bit more harder one. So 54. Let's use an 8-bit register. So 54 is 32 plus 16, which is 48 plus 4 plus 2. 2 to the 5 plus 2 to the 4 plus 2 to the 2 plus 2 to the 1. 2 to the 1. 1, 2, 3, 4, 5, 6, and 7. And 8. 2 to the 1, 2 to the 2, 2 to the 4, and 2 to the 5. Alright, what is 21? It is 16 plus 4 plus 1, which is 2 to the 4, 2 to the 2, and 2 to the 0. 1, 2, 3, 4, 5, 6, 7, and 8. 2 to the 0, 2 to the 2, and 2 to the 4. Let's add these up. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. You carry 1 over. 1 plus 0 is 1. And these match up right here. 1 plus 1 is 0. Carry 1 over. Which is 1 plus 1 plus 0. Which is 0. You carry 1 over. And 1 plus 0 is 1. 0 plus 0 is 0. And that is our answer. So this is the last one. I hope you guys enjoyed the video. It was a little bit more different doing a binary addition. It can be a relatively new concept and a little bit more difficult just trying to see the patterns. But I hope you guys enjoyed the video. So here's the last question. I do implore you guys to try to go over these questions and try to answer this question. So if you can, pause the video and do this last one. But I'll just go ahead and get started. So 81 equals 64 plus 16 plus 1. 119 is 64 plus 32 plus 16 plus 4 plus 2 and plus 1. I believe that is 119. Let me check. Yes, it is. And we are using an 8-bit register. So 81 is 2 to the 6, 2 to the 4, and 2 to the 0, 2 to the 6, 2 to the 5, 2 to the 4, 2 to the 2, 2 to the 1, and 2 to the 0. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. 2 to the 0. 1, 2, 3, and 4. 5 and 6. 2 to the 6. 2 to the 5. 2 to the 4. 2 to the 2. 2 to the 1. And 2 to the 0. Fill the rest with zeros. Alright. Alright, so let's figure this out. 1 plus 1 is 0. Carry 1 over. Same exact thing. 1 plus 1 is 0. Carry 1 over. Same thing here. 1 plus 1 is 0. Carry 1 over. 1 plus 0, 0, which is 1. Here, 1 plus 1 is 0. Carry 1 over. Same thing here. Carry 1 over. This one we haven't seen in a little bit. We have 1 carry over because of these two. And this one stays. So 1 here. And then we have this one carry over. And we are left with this. So let's see. 0, 1, 2, 3, 4, 5, 6, and 7. So 2 to the 7 plus 2 to the 6 plus 2 to the 3. Alright, we are left with 128 plus 64 plus 8. And that is 200. Alrighty guys, well thank you guys for watching. If you guys want to hear from me again and see the rest of this computer organization course, please leave a like, comment, and subscribe for some more educational content. Have a blessed day.